The weight in kilogram of 15 rugby players in the Rebels Club and 15 soccer players in the Sharks Club are shown below. For part A, we are to represent the data by drawing a back-to-back stem and leaf diagram. The labels must be on the left-hand side of the diagram. If you look at this, the data are already arranged in ascending order. The minimum value for both these data sets is 66, and the maximum is 102. So when we are drawing a stem and leaf display, then we can use 6 through 10 for the stem. For part A here. So from here, the stem that we have 6, 7, 8, 9, and 10. And we are to have the rebels on the left side and the sharks on the right. So let's start with the rebel. We have 75, 78, 79, 80, 82, 2 of them. Then we have 83, 4, 5, 6, 9, and then we have 0, 2, 2, 3, 4, 5, 6, 9. Then we have 93, 95, 99, and 102. For the sharks, we have 66, 68, 71, 72, 74, 275, 76, 78. And then we have 83, 83, 84, 5, 6, and 92. Okay, for a stem and leaf display, we need a key. So you need to specify the key. Let's look at this part here. So if you are to look at this part, we have 5, 7, 1. So this key means that we have 75 kilogram for rebels and 71 kilogram for sharks. Okay, make sure you include a key for your stem and leaf display. Otherwise, you may have marks deducted. For part B, for the rebels, we need to find the median and the interquartile range. It's easier to get the median and the interquartile range from the data set given since it has already been arranged in order. So we need to find which data is the median. There are 15 players, so there are 15 data values for the median. To find the median, what we have is that we need to find the location of the median first. Median, so we have 0.550%. So we take 1/2 multiplied by 16 here. 15 plus 1 is 16. You add 1 to the number of data values, that will give us an 8. So data number 8 is the median. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 is 84. And over here, we say that the median is 84. We have 84 as the median, and we need to find the interquartile range. So to find the interquartile range, we need to find Q1, the first quartile, and the third quartile. The interquartile range is the difference between these two. This is the median, so excluding the median, this is the middle of the data values. So Q1 is 80, and excluding the median, we look at this part here, the middle data value is 93. So Q3 is 93. The interquartile range is the difference between Q3 and Q1. We are 93 minus 80. Then the interquartile range is 30. And they are all in terms of kilograms. A box and whisker plot is given below. And part C, you need to draw a box and whisker plot for the rebels. So let's look at the rebels here. For the rebels, you see that for the rebels, your Q1 is 80, your median is 84, and Q3 is 93. So Q1 is 80, that will give us a Q1 here. So let's just draw 1, 2, 3, 4, then the middle is here. So we have Q1 is at 80, and then Q2, median is 84. So 81, 82, 80, you have 84 here. That will be your Q2. And then we have 93 for Q3. So this will form a box. Okay, the whisker will extend to the minimum. The minimum for the rebel is 75, and the maximum is 102. Then the whisker will extend to the minimum, which is 75. 1, 2, 3, 4, 5. That will give us the minimum. And this is where the whisker extends to. The maximum is 102. That is 102. So the whisker will extend to 102. That will give us the box plot for rebels. Part D, make one comparison between the weights of the players in the rebels club and compare it to the sharks. Now this part is for rebel. And you notice that the entire box plot for the rebels is to the right, well, slightly to the right for the sharks. From here, you can see that the average, if you compare the median for the rebels is greater than the median for the sharks. Well, median can be used to represent central tendency, which is the average as well. We can say that the average weight of rebels is higher than the average weight of sharks. You can see that the median for rebels is greater than the median for sharks.